the series parallel is possible or not. In that particular circuit, if the series parallel is possible, then we have to do that series parallel. If the series parallel is not possible, then we prefer the star and delta converting. So here in this circuit, so here we are calculating the equivalent resistance between these 2 points. Right? Start from the another end side. Here 2 ohms, next immediately connecting 10 ohms. So what is the possible combination of 10 and 2? Is there any series parallel possible? Is there? This 10 and 2. 10
Sir,
and
middle
2 is
resistor value इवाले sir.
acha. Assume it is 1 ohm. Okay, 1, 2, or assume it is 3 ohms. So 10 and 2 ohms are series. So 10 plus 2. 10 plus 2 is how much? 12 ohms. Then next level circuit diagram. Here it is.
Error method use చేయాలి ముందుకు వెనక్కు జరుపుకుంటూ
Yeah. So here it is 12 ohms. Then here it is 6 ohms, 4 ohms, 7 ohms, 9 ohms, 3, then 5, 8 and 6. Now these two elements 12 and 6, these two are parallel. So 12 parallel with 6. So that is 12 into 6 by 12 plus 6. How much it is? Calculate fast here. Do it fast.
4.
How much?
4, sir.
4 ohms. So here what I'm doing, so same circuit diagram law, I'm removing these two elements, then the resultant, see observe the step by step. The resultant is here 4 ohms. 4 ohms. Now next level, that is 4 and 8, that is series. 4 plus 8, that is 12 ohms. Now again I am removing these two element and make it only here. It is, its value is 12. Its value is 12 ohms. Now 12 ohms and 3 ohms, these two are parallel. So that is next level. That is next level is 3 into 12 by 3 plus 12. How much it is? 3 into 12.
2.4.
2.4. 2.4.
Yes, sir.
Yeah. Then next level, again I am removing these two element, right? Then the resultant value, this value is 2.4. Next to this 2.4 and 5 ohms, these two are series. So that is 5 plus 2.4. How much it is? 7.4. Then next level, see, please do not confusion, step by step. Here it is 7.4. The next level is, that is 7.4 and 9 parallel. So 9 into 7.4 divided by 9 plus 7.4. How much? 16.4. How much it is? Calculate.
4.06.
4.06. 0.06. Then next level, I am removing these two element, and I am making only one resistor. How much it is? 4.06. Now this 4.06 in series with 4. How much it is? 8.06.
8.06.
So now again I am removing this two element, right? I'm connecting only one element, that is 8.06. Now next level, that is 8.06 and 7. What is that combination? Parallel. 8.06 into 7 by 8.06 plus 7. How much it is?
3.7.
3.7.
3.7
7.
ohms. So now again I am removing these two element, and now I am connecting only one element, that is 3.7. Then what is the equivalent resistance between AB points? R equivalent or RAB, right? How much it is?
9.6.
The 6 and 3. What is the combination? Parallel or series?
Series.
Series. That is
Series.
6 plus 3.7. How much it is?
9.7.
So here, see, generally in this circuit, basically it look like say star delta. But my suggestion is star delta only preferable if series parallel is not possible. Then only star delta is preferable.
Yes, sir.
Yes. Okay, na? Bandaru, clear?
Okay, sir.
Yes, yes, sir.
Yeah.
Sir,
Yes.
how sinusoidal waveform is represented as phasor quantities?
Sinusoidal?
Sinusoidal waveform is represented as phasor quantity with example.
Yeah. See, these are the two sinusoidal quantities. That is in phase lagging leading. Suppose here we have the two alternating quantities. Here, see, this is the sinusoidal quantities. Zero pi, 2 pi, right? This is one sinusoidal quantity. Suppose here we have the another sinusoidal quantity. Exactly here it is. I assume that here it is pi by 2. Then, yeah. So one another quantity is started from here. So these are the two sinusoidal quantities now. Yes or no? I assume that it is V1, that is Vm sine omega t. Then another one is, this is V2. V2 is equal to Vm sine omega t minus pi by 2. Because of here, the V2 is started here. V2 is started here before starting the V1. Then here, what is the pi is equal to? What is the angle between the here two V1, V2? What is the angle here? Pi by 2. So in the phasor, suppose here I am considering V1 as a reference one, right? Because of sine omega t here it is started from 0, though it is reference one. Then V2, either here V2 it is lagging or leading. Is that lagging or leading?
Lagging.
Lagging, sir.
Lag,
Lagging.
lag, lagging by how
Lagging by
much?
5/2. 5/2.
Right?
5/2.
So here lagging means where I have to draw. Here it is lagging, right? This is V2, right? Then here angle. What is the pi here? Pi is equal to pi by 2, right? Here not minus pi by 2. This minus sign indicating it is a lagging, right? Is this clear?
Yes.
Yes, sir.
Yeah. ఇంకా ఇంకేమైనా డౌట్స్ or shall I
Sir,
start the
variable
transformer?
frequency. Variable frequency, sir. That's some.
Yeah, okay, the awesome.
Sir, you said you will solve now, sir.
Uh,
You said you will solve and send now, sir.
sorry, I'm not getting you.
Yesterday, same doubt, sir. You said you will say
Which one?
about a variable frequency, sir.
Yeah, now here that a coil is connected in series with a capacitor of 20 microfarads to a 200 volts. So here problem is C is given. C is how much here? 20 microfarads. 20 into 10 to the power minus 6 farads. Then V is equal to how much it is? 200 angle of 0 because of angle is not given. Then yeah, it is variable frequency supply. The current is a maximum at 50 amps. Here Im value is given, maximum current value is given. How much it is? 50 amps, right? When the frequency is set to 50 hertz, f is equal to 50 hertz, right? Determine the resistance and inductance of the coil. So what we have to calculate here? L and what is another one? Yeah, R. Okay, so these are the things we have to calculate, L and R. See, so here maximum value given. So in AC circuit, we know that I is equal to V by Z. I is equal to V by Z. Here IRMS is equal to VRMS by Z, right? So here the voltage 200 volts it is given. Is this maximum value or RMS value or instantaneous value?
Maximum value is given, sir.
No, that is not maximum value. Many times I said that if it is specifically not mentioned, if it is not mentioned specifically, assume that it is RMS. Assume that it is RMS. So here VRMS is given. Then IRMS. IRMS is equal to what is the formula? Im by root 2. అదే కదా మనకు IRMS is equal to Im by root 2. That is 0.707 into Im. So Im is how much here? 50, right? By root 2. 50 by root 2. How much it is?
35.35.
Yeah, 35.35. 35.35 sorry, amps. 35.35 amps. Now step by step. So now here IRMS we calculated. IRMS just now we calculated, right? Then we know that VRMS. Then can we calculate the Z? Z equivalent is equal to what is that? VRMS by IRMS. Here just calculate the magnitude, that's enough. V is equal to how much? 200. IRMS 35 by 30, 35.35. Calculate it.
5.65.
5.63, sir.
Hmm?
5.63.
5.63.
5.7.
Right. Then next, yeah. Then XC. XC. Can I calculate the XC? XC is equal to 1 by omega C. That is 1 by 2 into pi into F is equal to how much? 50 into C is equal to how much? C is equal to how much it is given?
20
20
into
into
10
10
power
power
minus.
minus 6.
How much it is? 20 microfarads. 20 into 10 to the power minus 6. Calculate it. How much it is?
159.09.
Hmm. How much?
159.09, sir.
Two into pi into 50
159.23.
20 10 to the power minus 6. Yeah, XC is equal to 159.15, right, ohms. Then next what we have to calculate? Echo Z is equal to under root of R square plus XL minus XC. Here R is unknown, XL is also unknown. Coil is connected in series with a capacitor of 20 microfarads to a 200 volts variable frequency. The current is maximum at 50 amps when the supply frequency is set to 50 Hz. Resistance and inductance of the coil. XL is equal to, here we have to calculate XL value. First, how to calculate the XL value? 1 second. Maximum at 50 amps when the sub frequency is set to be here. If it is variable frequency, we will do one thing. Variable frequency, this variable frequency, when the frequency are varying from 0 to some extension, at some point, that is XL is equal to XC. XL is equal to XC. This is resonant frequency. Where XL is equal to XC, if it is resonant frequency, then XL is also 159.15 ohms. So if it is XL is equal to 159.15, then XL is equal to, yeah, XL is equal to omega L. Omega is equal to 2 pi FL. So that is 159.15. Of r square plus xl minus xc. Here this term xl minus xc, if it is equal to, if it is equal, then it is 0. Then here z is equal to your r, and it is equal to how much? What is the z value? This is the meaning of the variable frequency. What is the z value? How much we got the z value? Guys,
5.63, sir.
5.63 ohms. We calculated R value, we calculated L value. Here not ohms, here henries. L is the inductance, 0 point, how much it is?
0.50.
50.
It is henries. Yeah. Yeah, Charini,
Yes, sir.
Charini,
Yes,
ఆ
sir.
ప్రాబ్లం కి కింద ప్రాబ్లం అది కంప్లీట్ ఫుల్ గా పంపించు.
Okay, sir.
ట్రాన్స్ఫార్మర్ ఆ ప్రాబ్లం కూడా చేద్దాం.
Yes, sir.
కొంచెమే ఉంది ఇందులో.
Sir, I sent you. It's the 6th problem, sir, in that paper.
Yeah. 6B, that is transformer related problem. That is in that question paper. That is, yeah, some question that is. Yes, write down the problem. Please note చేసుకోండి ఇది. A 50 kVA, a 50 kVA, లేకపోతే చరణి ఒక పని చేయి తల్లి, మళ్ళీ టైం
Yes,
వేస్ట్. ఇక్కడ చాట్లో ఆ క్వశ్చన్ పంపు, అందరికి అవైలబుల్ ఉంటుంది కదా.
Okay, sir.
డైరెక్ట్లీ మనం డేటా రాసుకొని సాల్వ్ చేసుకుందాం. అది బెటర్ కదా, టైం సేవింగ్.
Yes, sir.
సార్ నిన్న కిట్స్ ఆఫ్ లా వోల్టేజ్ లా పంపించాను కదా సార్ ప్రాబ్లం
చేద్దామమ్మా. ఇప్పుడు ఒకటే టాపిక్ మీద 100 ప్రాబ్లం చేయడానికి అంటే టాపిక్స్ వేరియేషన్ చేద్దాం. మళ్ళీ ఇవి అస్సలు మనకు టైం లేదు కదా. యు గాట్ మై పాయింట్. ప్రాబ్లమ్ is the 50 kVA, P is equal to 50 kVA, then 1000 by 10,000. So here 1000 means V1 is the 1000 volts. V1 is the 1000 volts. V2 is how much? V2 is the 10,000 volts. V2 is the 10,000 volts. Then F is equal to 50 Hertz. single phase transformer has iron loss of, that is PI. Iron losses we denoted with PI, that is 1200 watts. Right? The copper loss that is PC with 5 amps in the high voltage winding. Right? In high voltage winding side means secondary side is given. So that is PC is 500 watts. Right? Calculate the efficiency, that is these are the given data. Then what is the required data here? Required data is that we have to calculate the efficiency. At first bit. Calculate the efficiency at 25%. Yeah, 25% of full load. Whatever that load, it is 25%. Right. Second bit is 50%. Third bit is 100%. Third bit 100% kada? Right? Of normal load at power factor of cos pi given. Cos pi is equal to how much? 0.8. This is the problem. So in this problem, first we calculate at third bit first చేద్దాం, ఎందుకంటే ఫుల్ లోడ్ దగ్గర మీకు ఒక ఐడియా వస్తే తర్వాత ఆఫ్ లోడ్ వాటికి చేయొచ్చు. సో ఫస్ట్ ఐఎమ్ క్యాలిక్యులేటింగ్ థర్డ్ బిట్.
Sir, second bit and third bit 50% full load, sir.
Yeah, first bit is 25%. అంటే whatever the full load, in that full load I am running the transformer at 25%. Here also it is 50% of full load. 50% దగ్గర అంటే దాని ఫుల్ లోడ్ కెపాసిటీకి నేను 50%లో ఆపరేట్ చేస్తున్నా. దట్స్ ద మీనింగ్. సో హియర్ ఎఫిషియన్సీ 100% అంటే ఎక్కడ? ఫుల్ లోడ్. We have to calculate the efficiency at 100%. So here efficiency is equal, simple formula, efficiency is equal to transformer output power in kW divided by input power in kW. Right? If you want to the percentage efficiency, multiply with 100. Right? Transformer output power in kW by input power in kW. Now the same formula here. So suppose I don't know the input, then input is equal to ఎలా రాసుకోవచ్చు నేను? Output plus total losses of the transformer. Input is equal to output plus total losses in the transformer. Then what are the total losses are there in the transformer? Output plus iron losses plus copper losses. So now here in place of output power, here I am writing this formula. Right? So now efficiency is equal to output power in kW by output plus PI plus PC. Is it clear, guys?
Yes, sir.
Right. So now yes. So here, so initially, see here the transformer rating is given. That is, see ఇక్కడ స్టెప్ బై స్టెప్ మీకు అప్పుడు ల్యాబ్లో క్లాస్లో కూడా క్లియర్గా రాపిచ్చాను వర్డ్స్లో. ట్రాన్స్ఫార్మర్ అవుట్పుట్ పవర్ at full load in kVA. Whatever the kVA rating is given, what is that? That is the transformer output power in kVA. How much it is? 50 kVA. Avuna? 50 kVA. Then ట్రాన్స్ఫార్మర్ అవుట్పుట్ పవర్ ఎట్ ఫుల్ లోడ్ ఇన్ కేవీఏ. కానీ నాకు కేవీఏలో కాదు కావాల్సింది, ఐ వాంట్ అవుట్పుట్ పవర్ ఇన్ కేడబ్ల్యూ. సో దట్స్ వై హియర్ వాట్ ఐఎమ్ రైటింగ్, ట్రాన్స్ఫార్మర్ అవుట్పుట్ పవర్ ఎట్ ఫుల్ లోడ్ ఇన్ కేడబ్ల్యూ. Right? KW, what is the formula? KVA into cos pi.
Cos pi.
Right? గుర్తుందా ఇదేమన్నా?
Yes, sir.
అప్పుడెప్పుడో 1947 లో చదువుకున్నాం, గుర్తుందా? That is how much KVA it is. KVA is how much here? 50. 50 into cos pi is how much?
0.8.
0.8. How much it is?
40.
Sorry, 40 kada? Yeah, it is 40 kW, 40 kilowatts. Then here transformer rating is given. Here transformer current is given. At the secondary side, current is given. I2 is how much here? It is 5 amps. Avuna? Then P is equal to that whatever that KVA power, KVA in power, what is that formula? That is V into I only. Power in the transformer, power in the primary as well as secondary, it is same. Then if you are assuming P2 is equal to yes yeah. So then P2 is equal to V2 into I2. Then I2 here, yeah, P2 by V2. P is how much given? 50 kVA, 50 into 10 to the power 3. Voltage is V2 is how much given? 10,000. Calculate it.
Five, sir.
So whatever that I2 current given, it is full load current, 5 amps. Just I'm cross checking either it is the current is either it is full load or not. So here, yeah, so we got that output power in kW. Then yeah, then efficiency at full load, that is output power in kW by output plus iron losses plus copper losses. If you want percentage, multiply into 100. So what is that output power in kW? How much it is? 40 kilowatts. 40 into 10 to the power 3 by 40 into 10 to the power 3. Iron losses value is given. How much it is iron loss value?
1200.
Right? At full load, the iron losses value is given 1200. Then copper losses, whatever. See here the copper losses here P2, I am considering 50. It means full load. Then full load copper losses is given. How much here it is copper losses? In teacher copper losses
500.
500.
500, right, into 100. Can you calculate it?
95.92.
95.92%. This is the efficiency of the transformer at full load. Now second bit we have to calculate. Second bit calculate chestunnam first. Efficiency at 50% of the full load. It means half load. Yes or no? Efficiency at half load. 50% ante half load e kada?
Yes.
If it is
Yes, sir.
Yes, sir.
right, then Now here also same formula. What is that efficiency? Output power in kW, output power in kW by output plus iron losses plus copper losses. So now here, yeah, then transformer out, please జాగ్రత్త అబ్జర్వ్ చేయండి. ట్రాన్స్ఫార్మర్ అవుట్పుట్ పవర్ at half load, 50% of the load, half load in kVA, half load in kVA. In kVA, what is the half load? Full load 50 kVA, half load అంటే ఏంటి, ఏం చేస్తాం, 1/2 into 50. How much it is? 25
25.
kVA. Then now transformer output power at half load in kW. kW is equal to, what is the formula? That is, kW is equal to, what is the formula?
KVA into
kVA into cos pi. Then kVA is how much here? That is 25 into cos pi, 0.8. How much it is?
20.
How much? 20
20.
kilowatts. Units kuda cheppandi. Then, yeah, coming to efficiency, here I am writing. Yeah. So output power, how much it is? 20 kilowatts. 20 into 10 to the power 3 by 20 into 10 to the power 3. Right? Then now tell me, yes, at full load, here observe. At full load, what is the iron loss value here? 1200. Huh? Oh no?
Yes.
At
Yes,
full
sir.
load, iron loss value is 1200. Now tell me, at half load, what is the iron loss value?
1200.
600.
Yes, Akila. At half load, what is the iron loss value?
Same.
100.
They are constant, sir. Constant losses.
Same.
Yeah.
Same.
What is that? The other name of iron loss is, the other name of iron loss is constant losses, right? These losses will not change at any load, right? Either once the transformer, not only in transformer, motor, generator also, once the machine, electrical machine is designed, once it is manufactured, after that we cannot change these losses. These losses will not depends on that load. Either you are running at full load, half load, quarter load, or no load, whatever. These losses will not change. So here we can write down it is a constant. Now here, how much it is? How much we have to consider here? 1200, right? Then what is the other name of copper losses?
Variable losses.
Losses.
Variable losses. So these losses will change according to load. If the load is changes, these losses will change. So at full load దగ్గర copper losses 500 ఉంది. At full load the copper losses is PC at full load. Can you tell me what is the at half load, what is the PC value?
500/4 x square, sir.
Is that?
1/2 whole square into 500.
500.
So here copper losses will change. Here the point is, I am writing the point. Copper losses are the variable losses, and these losses will change according to load. So at X load, copper losses will change X square factor, right? So here how much it is changing here? That is load off అయింది కాబట్టి 1/2 whole square into 500. into 100. Calculate it. Calculate it. Abba.
12.5.
Hmm. How much? Efficiency.
93.78.
93.78%. Right? Third bit మీరు చేయలేరా 25%?
Yes,
Yes,
sir.
sir.
By 4.
Yeah.
Yes, sir.
Here the again yes. ఇంకేదైనా ప్రాబ్లమ్స్ పంపించండి.
Sir, there is a problem where we need to find out line voltage, line current, phase voltage, and phase current, sir.
Where? Which problem? Send me that problem.
Sir, I sent you, sir, in that 4B, sir.
Four B. Yeah. Yes. That is 4B. Again, send it here in MS Team also.
Yes, sir.
Just I'm writing the directly data. That is 4B gada. A balanced delta connected. Here the problem is here balanced means the meaning of balanced means in delta we have the three impedances. All these three Z1, Z2, Z3 has the balance, the same value. So here problem balanced delta connected. Balanced delta connected load with a per phase impedance. So here per phase Z per phase is given. Z per phase is how much here? 12 plus J 9. 12 plus J 9 ohms is supplied by a 400 volts. Here V is equal to 400 volts. Then F is equal to 50 Hz. F is equal to 50 Hz. Three phase. So determine the phase voltage. So here these are the required data. First one is how much? What is that? Determine phase voltage. V phase. Second one what we have to calculate? Line voltage. IL. Third one line voltage and current in each phase. Phase voltage, line voltage and current in each phase. So current, sorry, this is V phase, VL, then I phase and IL. So here impedance. So the circuit is like this. Here just I am drawing that. Here first of all try to understand this here 12 plus J 9. What is this? What is it mean by 12? What is this plus indicating? What is this J9 indicating?
Rectangular, sir. Plus in the sense positive. Like
నేను ఇప్పుడు ఇక్కడ లోడ్ డ్రా చేయాలి. Okay, try to understand here my concept. Yes, 1 second. ఎవరమ్మా నిద్రలో మాట్లాడుతున్నారు? B3 నిద్రలో మాట్లాడుతున్నావు తల్లి. Right. So here it is that delta connected. So here resistor here plus indicating here the Z is equal to actually here Z is equal to R plus like R plus J. This XL la XC na.
L, sir.
How can you say that it is L?
Because there's plus sign bleeding.
Because of plus sign. That's why XL. So here, so that is this is one phase in then here this is the delta. Then in each phase, these are the 3 points in each phase. Here it is A point, here it is B, R, Y, B, 3 phases. Then each phase Z is equal to given here. Z1 is equal to 12 plus J9. Here also it is Z2 anukunte 12 plus J9, Z3 12 plus J9, right? So this is the circuit. So what we have to calculate here in delta connection, we derived that equation. In star connection, current is same. Avuna? Yes or no?
Yes, sir.
In delta connection, voltage is same. So first bit, what we have to calculate? Phase voltage. So here VL, that is 400 volts. So that is VL is given. Yeah, VL is given 400 volts. Then we know that VL is equal to V phase. Then how much it is?
400.
400 volts, right? Then I phase calculate cheyamaru, right? Then I is equal to, in AC circuit, I is equal to what is that? V by Z. Avuna?
Yes, sir.
I
Yes, sir.
V by Z. Then I phase is equal to ఎలా రాసుకోవచ్చు? Just V phase by Z phase. V phase is how much here?
400.
400. Z phase is how much here given?
Root of
12 plus J9. Just magnitude calculate చేయండి ఇక్కడ. 400 divided by, that is under root of 12 square plus 9 square. Just we will get that magnitude. How much it is?
15.
15.
How much? 15?
1.5.
15 ఏంటి అది?
Ampere.
15
మరి
amperes.
చెప్పండి, ట్యాగ్ తగిలించండి, right? 15 amps. Then line current. How to calculate the line current here? IL is equal to, what is that? Root 3
26.6
into
amperes.
26.6 amperes, sir.
Not 12 square plus 9 square is 15.
15.
Mhm.
15. Total
So
26.6 amperes.
ఎక్కడ టోటల్ కరెంట్ అమ్మా?
I phase, sir. I
I-
phase
ఇక్కడ
26.6
మీరు
amperes.
మీరు 15 అన్నారు ఇందాక.
అంటే 12 square plus 9 square.
అచ్చా, దాని వాల్యూ చెప్పారా?
Yes, sir.
దట్ ఈస్ 400 డివైడెడ్ బై 15. ఇప్పుడు హ్యాపీనా? ఇప్పుడు చెప్పండి ఐ ఫేస్.
26.6.
26.6 amperes.
Now IL is equal root 3 into I phase. Root 3 into 26.6. Calculate it. ఎంతసేపా?
46.07.
46.07
amps.
amps. So IL, I phase, then VL, V phase.
Sir, it is 28.3, sir. Root 3 into 26.6. 28.33.
ఒకసారి మళ్ళీ చెక్ చేసుకున్నానా, ఇట్ ఈస్ 46.07. దట్స్ రైట్.
Yes, sir.
నువ్వేం చేస్తున్నావు అంటే రూట్ కొట్టావు 3 into 26.6 is equal to కొట్టి ఉంటావు, రైట్? సో దిస్ ఈస్ దిస్ ఈస్ ఏదైనా డిఫికల్ట్ టైప్ ప్రాబ్లం? హౌ మచ్ ఇట్ ఈస్ సింపుల్? జస్ట్ డూ ద ప్రాక్టీస్. Just
Sir.
only thing, once again I'm telling that only thing is in star delta you have to remember in star connection and in delta connection. In star, current is same. The only one point you have to remember, IL is equal to I phase, right? Here if the current is same, then voltage must be difference. So VL is equal to, it should be difference. The difference is root 3 times difference. Either it is multiply with root 3 or divided by root 3. So VL is always greater than V phase.
Sir, once check the chat box, sir. Once check the
VL,
chat box.
ఇక్కడ ఫస్ట్ వినండి, root 3 into V phase. Then V phase, see just these two formulas. Here it is in delta, in star current is same means in delta voltage is same. That is VL is equal to V phase. Then here it is IL is equal to root 3 into I phase. Please remember this 4 relation. ఇక్కడ ఈ ప్రాబ్లంలో, ఇప్పుడు ఆ ప్రాబ్లం మనకి ఎన్ని మార్క్స్ అడిగారు? How many? 8 marks problem. Is that ఏదైనా ట్విస్ట్ ఉందా? It is very simple problem. రూట్ 3 ప్లస్ కాదు నాన్న, రూట్ 3 ఆకాష్ మల్టిప్లై అది.
ఓకే సార్.
నేను ప్లస్ అని ఎక్కడ రాశాను అక్కడ? ఓకేనా? రుత్విక్ సపోర్ట్ చేయవేంద్ర. P0 Shreya sent some questions.
Same question, sir.
Same question, sir. Charani asked me to send.
Okay. This is clear now?
Yes, sir.
ఒక్క 2 minutes wait చేయండి నాన్న. I will take the attendance.
Sir,
Yes.
source transformation method ఒక ప్రాబ్లం చెప్పండి.
ఏంటమ్మా సోర్స్ ట్రాన్స్ఫర్మేషనా? ఓకే. మీకు ఇప్పుడు మళ్ళీ ఈరోజు ఎప్పుడు ఫ్రీగా ఉన్నారు మీరు? 3 to 4 డిస్కస్ చేద్దామా ఈరోజు?
Yes, sir.
Yes, sir.
3 to 4.
Yes, sir.
Yes, sir. Yes, sir. Okay.
సో
Yes, sir.
షెడ్యూల్ చేసి మళ్ళీ పంపిస్తాను. 3 to 4 we will discuss again.
Okay.
ఇప్పుడు ఉన్న వాళ్ళందరూ అటెండ్ అవ్వాలి.
ఓకే సార్.
Yes, sir.
1 second నాన్న, నేను కొంచెం అటెండెన్స్ తీసుకుంటా.
సార్ ప్రీవియస్ ఇయర్ క్వశ్చన్ పేపర్స్ లో ఉండే క్వశ్చన్స్ కూడా డిస్కస్ చేయండి సార్.
ఇప్పుడు చెప్తుంది ప్రీవియస్ ఇయర్. ఇప్పుడు చెప్తుంది ఏ క్లాస్ నాన్న?
ఇప్పుడు చెప్తుంది థర్డ్ యూనిట్ ప్లస్ లాస్ట్ లో ఇది మాట్లాడుతుంది.
జొమాటో రీసౌండ్ వస్తుంది ఎవరో నా మాటలు నాకే వినిపిస్తున్నాయి ఒక్క 2 minutes. J1 J2 J3 J4 J5 J6 J7 J8 J9 K0 K1 K2 K3 K4 K4 to K9 L0 L1 L2 L3 L4 L5 L6 L7 L8 L9 M1 M2 M3 M4 M5 M5 M6 M7 M8 M9 M0 M1 M2 M3 M4 M5 M6 M7 M8 M9 P0 P1 P2 P3 P4 P5 P6 P7 P8 P9 Okay, Nana, you can leave.
Sir,
Ah,
sir, I have just one confusion here. In delta connection, given V value will be VL, no sir. But in star connection, given V voltage value will be V phase.
no. If it is given, if the same problem, if it is the same problem, if it is star connection, whatever that 400 volts is given, na,
Yes, sir.
that is line voltage.
Okay, sir. So here in
Yeah.
delta also given is line voltage only.
Yes.
Okay, sir.
If it is delta, we don't have any problem, either it is line or phase.
Both are same only.
Both are same, na. But generally it is 400 or 420, 440. It means it is line voltage.
Yes, sir.
Okay. Devarkonda,
Sir,
any doubts?
ఈవినింగ్ 3 to 4 పంపిస్తాను సార్ అప్పుడు చెప్పండి.
Okay.
థ్యాంక్స్.
Arun, J2 Arun Sharma.